So classes today,
Yeah, so we can start the session, right?
yes, but classes today end at 9, right?
Yeah.
We have started like 20 minutes later, so we'll end 20 minutes later, obviously, because we'll not give the session
Oh
only
no,
for
I'm sorry. I thought my aunt said that I could come out at 9.
Yeah, tell them it's fine.
She said it's
9 is
fine.
fine. We'll
yeah.
just go from 8 to 9.
8
Mm-hmm.
to 9.
15 minutes won't kill her of not having classes.
You heard her?
A little bit, 15 minutes. What?
She said
Mm-hmm.
she said 15 minutes of no classes won't like kill me like a
Yeah.
lot. You know?
Yeah, that's right. But I will not feel better like if I'm giving sessions less than 1 hour. Like for my set, if it is possible for you to have the session till 9:15 at least, then we can. If not, then we can stop at 9. No problem,
Okay.
right? So what we can do here is we can start the session. We were having chapter 1. Last time we discussed about the numbers, natural numbers, whole numbers, rational numbers, irrational numbers, and I had given you a few questions as a homework. You remember?
Yes.
So did you try them?
I did them on the
Can
the
you
um
on your rough note, right?
like I did them on this board right here, the whiteboard.
You did it here?
Yes, I circled my answers in black.
Yeah, but I'm able to see only question number 2 is answered as B, that's right. And 1 is answered as option A, that's also right. And 4th is -2AC. But what about the other ones, like question number 3, question number 6?
I'm sorry, I thought I was only supposed to do 3 questions.
Oh, okay. So let us try 1 second. See, I have given you 5 questions on the top also. Question number 1 and 2 we had not done. Question number 6 was the homework, and I had written here 8 questions homework. You see here?
Remember when I couldn't get into this whiteboard?
Oh
I did
yeah.
all of the questions on paper.
Oh yeah. I got it. So what were the answers? Can you tell me?
I don't know them like off my head, but I still have them written down.
Yeah, that's can you spell them? Like, can you tell them what are they? Are they in front of you?
No, I'm sorry.
Oh, okay. So what you can do here is we're having one more session tomorrow. So what you can do, you can just mark the answers on page number 8. It's written page number 8 here, and page number 10. You can mark the answers again so that I can see them before our session, right?
Right.
All right. So today we're going to do the questions related with numbers, rational numbers, irrational numbers, decimals, natural numbers, integers, and so on. So before going for questions, I'm gonna give you one example here. There's a number that is 2. So we have to classify 2 is which number? Is it a natural number? Can you tell me, is it a natural number, a whole number, an integer, a rational number, or an irrational number?
It's a natural number.
Yes, it is a natural number. That's right. What about whole number? Is it a whole number? Because all natural numbers are whole numbers because they're also complete. They're also, full numbers. As last time we did, natural numbers started from 1, 2, 3, and so on, and whole numbers started from 0, 1, 2, 3, and so on. And integers are all whole numbers, 0, 1, 2, 3, and so on, and also negative numbers, -1, -2, -3, -4, and so on. So what about 2? Is 2 a whole number?
Yes.
Okay, what about 2 as an integer? Is it an integer?
Yes.
And we discussed about the definition of rational numbers. Do you remember anything about it?
2 is an irrational number.
2 is an
Is an irrational number.
uh, is rational or irrational?
Irrational.
Irrational. Why? Any reason specific why 2 is an irrational number? No.
No.
Uh, see, we have discussed last time. We have written it here. Are you able to see the writing? Rational numbers,
Yes.
integers, and everything, going on here. I will repeat it a little bit because this is very important. There are certain questions in which we have to know the definition of rational and irrational. So last time I told you that there are numbers which are, there are decimal numbers. For example, there are decimal numbers, and decimal numbers can be terminating. They can be like 2.5, and that's there, like there's nothing after 5. They can be non-terminating but recurring, that is 2.555555 and so on. This 5 is getting repeated. Or 2.657265726572, the 6572 is getting repeated. Or we are having a number that is, for example, 2.1239871928829, some random numbers after this 2 point some random numbers. So we're having decimal numbers which are terminating. For example, this 2.5. This 2.5 is terminating. This 2.5555 or 2.657 6572 is non-terminating. It's not stopping, but it is recurring. There's a number which is getting repeated. For example, 5 in the first option and 6572 in the second option. There's a number which is getting repeated. And in the third case, there's random number 12398712889, like something random going on. So here we can say those numbers, you remember the definition now, those numbers which are terminating or which are repeating, which are having some numbers which repeat. For example, 5555, it's repeating, or 6572 it's repeating continuously. Those numbers which are terminating or those numbers which are repeating are rational numbers. Remember, those numbers which are terminating or those numbers which are repeating, they're having some number which repeats continuously. They are called rational numbers. And those numbers which are random, you just see the last example, 2.12398719228 and everything, random coming here. Those numbers which are random, which are non-repeating, they don't repeat, there's no number which repeats, they are called irrational numbers. Very important. So decimal numbers can be either terminating or repeating or non-repeating. As simple as that. So we can go to the right side. So we're having, for example, 2.72. Which type of decimal number this is? Can you tell me?
As in like terminating?
Correct. It's terminating. Beautiful. So if it is terminating, is it rational or irrational?
I believe irrational.
No, it is rational because rational numbers are terminating. Rational numbers are terminating or they are repeating. Irrational numbers, on the other hand, are non-repeating, non-recurring, non-repeating. So 2.72 is terminating. If it is terminating, then that is rational number. Are you following?
Yes.
So 2.72 is terminating, and we can clearly say it is a rational number. What about 33.719?
It's terminating.
So if it is terminating, is it rational or irrational?
Rational.
Correct. So 33.719 is rational number. Okay, one more example. What about 29.72727272 and so on? So this 72 is getting repeated. Which type of decimal this is?
Not terminating.
Yeah, it is non-terminating, but is it repeating or non-repeating?
Repeating.
Correct, because the number 72 is repeating. So if it is repeating, is it rational or irrational? What?
Rational.
Correct, it's rational. So here again, it's rational because it's repeating. What about 91.236, and this 236 is getting repeated?
It's rational.
Right. Very good. So what about oh, I'll just mark one more number, pi. That's 3.141398297172698 and 3 dots. It's just continuously going on, but there's no number which repeats. So which type of decimal this is?
It's irrational.
Correct, it's irrational. So pi is an irrational number because it's non-repeating. It's not having any number which repeats continuously. So that is irrational. Now let us move to certain more examples. Going a little top. Okay. All right. So question number 1 is saying you, which of the following shows the numbers arranged in increasing order? So we have to first see what numbers, which option out of the 4 options are having numbers written in increasing order. And for that, we should know what is the value of every number, like what is root 3, square root of 3, what is square root of 10, what is 2 divided by 3, and so on, so that we can see which option is having numbers written in increasing order. And before that, I want to tell you something more related with square roots. Can you tell me what do you mean by square root of 4? Any
Pardon me?
idea? Can you tell me what do you mean by square root of 4? Any idea about it?
No. But I
All
think I
right.
know what the answer is.
What is that?
2.
Right. Square root of 4 means which number we can square so that we can get 4. Which number we can square so that we can get 4. We can square 2 so that we can get 4, because squaring means multiplying the number with itself. Again, 2 times 2. 3 squared means 3 times 3. 9 squared means 9 times 9. Right? 121 squared means 121 times 121. So if we are having square root of 9, that means which number we should square so that we can get 9. We should square 3 so that we can get 9, because 3 times 3 is 9. So that's where the answer will be. Square root of 9 will be equal to 3. So how much will be square root of 64? Any idea?
8.
8, exactly. So we can square 8 to get 64. So that is 8. Now let us write few numbers, few perfect square numbers. For example, 1 squared is 1. 2 squared is how much?
4.
3 squared,
9.
and 4 squared,
16.
5 squared,
25.
right? 6 squared,
36.
7 squared,
49.
8 squared,
64.
9 squared,
81.
and 10 squared.
100.
So at least these numbers we should remember, because they will be handy for solving few questions. So we got few perfect squares. Now if we are in need of square root of 4, how much will that be?
I'm sorry, say that one more time.
Yeah, if we are in need of square root of 4, how much will that be?
2.
Square root of 9,
3.
square root of 16.
4.
Right, so square root of 25.
5.
Very good. So that means, you know, when you go on like this, you are having some numbers, for example, 4, 9, 16, 25, 36, 49, 64, and so on. You're having certain numbers which are perfect squares. And perfect squares means when you square root them, you are getting a clean number. You're getting an integer. You're getting, you know, a whole number, an integer, 2, 3, 4, 5. You're not getting a decimal. Are you following what I'm saying?
Yes.
Now let us see. Square root of 4 is 2. Okay, square root of 9 is 3. But what about square root of 5? What about square root of 6? What about square root of 7? What about square root of 8? You know, those numbers which are in between them. What about square root of 21? What about square root of 37? There might also be some numbers which, when squared, will give you 37, will give you 26, and so on. 1 second, I'm sorry. Okay. So so there are certain numbers which are in between 4 and 9, but they are not perfect squares. Can you check on the calculator how much is square root of 5?
In decimal form?
It will be in decimals, I think, yeah. How much will it be?
It's like 2.236067997.
Okay, so it is a decimal number with random numbers after the decimal. Are you able to see that? There's no pattern.
Yes.
So can't we say that square root of 5 is an irrational number?
Yes.
In the same way, you will get square root of 6 as an irrational number, square root of 7, square root of 8, square root of 2, square root of 3, square root of all the numbers except perfect squares. You will get all the square root of every number as an irrational number except perfect squares. Only perfect squares will be having integers. 4, 9, 16, 25, 36, 49, 64, 80, 100. They will be having integers as their square roots, but any other number except these perfect squares will be all irrational. So if I have to say what is square root of 5, square root of 8, square root of 8, I don't need to even convert it in decimal form. I will say that it is not a perfect square because it is not 9, neither it is 4. So I can say that it is an irrational number at least. So what about square root of 15? Will it be rational? Will it be irrational or not? Square root of 15.
Irrational.
Irrational, exactly. Because we're not having any clean number which we can square so that we'll get 15. So that's why it will be irrational number when you will calculate it on the calculator. Now let us go back to the question and see the values of every number. So we have to write it in the increasing order, and if there's negative number, any negative number, that will obviously come before the positive number, isn't it? Because when you are going for increasing order, you're writing smaller numbers first, and then you're increasing and increasing and increasing. So how much will be negative square root of 3? How much is square root of 3? Can you calculate it on the calculator?
It's 1.732050
Okay. Okay,
eight
so
one.
so we know that it is an irrational number, right?
Yes.
So option A is having the first number as negative 1.732 and so on, and then negative 5, and then what is 2 divided by 3? How much is it? Can you check it on the calculator?
It's 0.6 repeating.
Correct. 0.6 repeating. I'm writing the bar on 6. That means it's repeating. And there we're having 4. How much is square root of 10?
Pardon me?
How much is square root of 10? Option A, last number.
3.16222. I mean, no, just two twos, and
Okay.
then 7766.
So square root of 10 is also an irrational number, right?
Yes.
So can you tell me, is option A written in increasing order? In which you're having the first number as negative 1.732 and so on, and then second one is negative 5, and the third one
No.
is 0.66. No. So option A is not the right answer. So out of these 5 numbers, which should come first?
-5.
So is there any option in which -5 is the first number?
C.
C. Let us see whether C is the right answer. -5 and then negative square root of 3, that means -1.732 and so on. And then 2 divided by 3, that is 0.6 repeating. And then square root of 10 is 3.162 and so on. And then 4, is it right? Is it written in increasing order?
Yes.
Yes, so this is the right answer. Did you understood this properly?
Yes.
Great. Now, before going for the second question, I want to know the classification of every number which is written here, which is written in the answer. Is -5 a natural number?
No.
No. Is it a whole number?
No.
Is it an integer?
No.
Can you see what is the definition of integers?
I'm sorry. Yes.
Because integers also contain negative numbers, 0, 1, 2, 3, and so on, -1, -2, -3, and so on. So -5 will also be an integer because it is a negative number and it is a complete number. So it is an integer, right?
Yes.
And all the integers, you know, with the closing of the eyes, we can say all integers are rational numbers because they are terminating. Because every integer is terminating. So that's why we say they are rational numbers. Every integer is a rational number. Because 3 can be written as 3.0000 or 3.0. So after the decimal, you're having 0 and that's getting stopped. It's a rational number. And the 0 is not having any value, so 3.0 can be written as 3. It is an integer. So I can say
Okay.
that any integer number is a rational number. So whenever you're having any number and you have classified that number as integer or whole number or natural number, then you can say that definitely that is a rational number. Right?
Yes.
What about negative square root of 3? That's -1.732 and so on. Random numbers after the decimal.
Irrational.
Irrational, exactly. What about 0.6 repeating?
Irrational.
0.6 and then repeating. After the decimal,
That would be rational, right?
right, it will be rational because rational numbers are either terminating or repeating. So it'll be a rational number. What about 3.162 and so on? Random numbers.
Irrational.
Irrational, exactly. What about 4? Is it natural, whole, integer?
Pardon me?
What about 4? Is it a natural number? A
Yes.
whole number?
Yes.
Integer?
Yes.
Rational number?
Yes.
Irrational number?
No.
No, correct. Beautiful. Wonderful. So this was question number 1, and we understood the different numbers. We can classify every number now. Can you try question number 2 here and tell me what is the answer? Just try it on your rough, or you were, how did you mark the answers? Like, how did you write it on the screen?
I just circled it.
Oh, But you have written also somewhere 17. How do you write 17? By your hand, like finger?
Most likely. Yes.
Oh, it seemed to be very professional. That's why. I thought you're having a pen tablet, as I'm having a hardware pen tablet. If you're planning for, doing the sessions online, maybe for 1 or 2 years, or a few months, then it's better to buy Wacom pen tablet. It's, I think, maybe $10-20, I believe. But you can, do as I'm doing. You can mark as I'm marking. You can write as I'm writing on the screen. I can give you the link if you want. So let's have question number 2. Can you try question number 2?
Yes.
So try it and tell me the answer. You need to do the PEMDAS. You're doing it right.
Yes.
Yeah. Okay. I'm waiting.
May you zoom into it?
Yeah, sure. So, anything you got? So which
It
one
would be B.
Which option?
B.
Correct. So you started with 2 minus 0.8 squared, right? Isn't it?
Yes.
Okay. And then you again did the parentheses and then exponents and multiplication or division, whichever come first, addition, subtraction, whichever come. Is there any confusion in using PEMDAS?
No.
Great. Now let us move to question number 3. We're having just using of the calculator for this question. So which calculator you're having? Madison,
Yes.
which calculator you're having?
My computer calculator.
Okay, okay, right. But in case when you want to give the exam, you have to take the calculator with you, right?
Yes.
So for that, you need to have one calculator. I think TI-83 or TI-84 Texas Instruments. That'll be better. So try to do question number 3 as a homework. It is just, solving on the calculator. Now, question number 4. We'll go to question number 4. So we'll be having question number 4. I'm zooming in. Can you read question number 4?
Which of the following is an irrational number?
So can you tell me? What about negative 1.2? Is it an irrational number? Is it terminating, non-terminating, repeating, non-repeating?
Would it be D?
Correct. Great. Yes, that's right. Because this will be having a value of which is negative, I don't know how much. How much was that? Square root of 10. How much was square root of 10?
Okay, it's a lot. Okay, 3.162277, and then a bunch of other numbers.
Okay, so square of 16 is 4, and there's a negative on its outside, and 4 divided by 3 will be, how much will be 4 divided by 3?
1.3 repeating.
Okay, and there's negative 1.2. Negative 1.2 is terminating, so it is a rational number. 1.3 repeating is repeating, so it's a rational number. Negative 4 is an integer. It's not a natural number. It's not a whole number, but it's an integer. And negative 3.162277 and the bunch of numbers, random numbers. This is a random number after the decimal, so it is irrational number, and that is the answer for question number 4. Can you tell me answer to question number 5?
Can you zoom into it?
Yeah, one sec.
Would it be B?
B, square root of 49 divided by square root of 64. That is correct. You're right. Question number 5 is option B. It's written in the answer script also. So that is option B. And why is it option B?
Because it's rational.
And why is it rational? What is the reason for this being rational?
Give me 1 second. I'm sorry.
No problem. Yes, Madison, what you're like working for?
May you look in the chat?
Yeah.
Okay, so it's rational because
Mhm,
it's a if you put it in decimal form, it's
mhm.
repeating.
Great. Or else you can do, what you can do here is you can give the square root to 49 also and square root to 64 also. So how much is square root of 49?
7,
And square root of 64?
8.
So when you check 7 divided by 8, it is repeating, right?
Yes.
So that's why we say that option B is rational number, not option A, not option C, not option D. That's right. So we can go to question number 6 and 7, and then we can stop. So can you read question number 6?
In 3 plays, a football team loses 5 yards and then gains 32 yards by completing a pass. Then, a penalty was called and the team lost 10 yards. How many yards did the team actually gain?
Right. So we had to just, play with the numbers. Losing 5 yards, doesn't that mean -5?
Yes,
And gaining 32 yards, what does this mean?
plus 32.
And then penalty, having a penalty of and losing 10 yards again, how much is that?
Minus 10.
So what is the value of this? -5 plus 32 minus 10.
$17.
That's correct. 17 is the right answer. Now question number 7. Can you read this?
Okay. On the number line above, if BC equals 2AB, what is the value of X?
All right, so the length of BC is equal to twice the length of AB. And if we know the length of AB, then we can calculate the length of BC. And then eventually we can calculate the value of C. But in order to calculate the length of AB, what should we do? It's a number line actually, but we don't know how much is in between A and B. How do we do that? Any idea? For example, there's a number line here, 0, 1, 2, 3, 4. And I'm having 2 points. One is on 2 and the other is on 4.5, point A and point B. How much is the distance between A and B? How much will be the distance between, from A to B? How much will be the length from A to B? If I'm having 1 point on 2 and the other point on 4.5. 2.5, exactly. How did you got that?
I went over 2 points, and then since we're not going fully to 5, it would be half.
Or else what you can do here is you can write higher number minus the lower number. That's 4.5 minus 2, that's 2.5. Isn't it?
Yes.
So we can calculate the length also by doing this thing, higher minus lower. And we can do the same thing here. Which is bigger number? Is it -0.4 or -1.25? Bigger one. Higher one. Not more negative. Because the more negative you go, the more lower the number is. So how much will be, like which one will be the bigger number? Is it -0.4 or -1.25?
Repeat the question.
Yep. Out of the two numbers, -1.25 and -0.4, which number is bigger?
Negative 0.4.
Correct. -0.4 is bigger. And I have told you, in order to calculate the length between A to B, you will go from the higher number and then subtract the smaller number, lower number. Higher minus lower. Bigger minus smaller. So negative 0.4 minus negative 1.25, isn't it?
Yes.
So how much will it be? How much will this be? Negative 0.4 minus negative 1.25.
It would be 0.85.
0.85. That's correct. That's correct. So AB is 0.85. And what about BC? How much is BC?
1.7.
So you're doubling it, right?
Yes.
So 1.7. So BC is 1.7. So then if the length between B to C is 1.7, how much will be C? As we know, higher minus lower is equal to 1.7. Higher minus lower is equal to 1.7. So how much will be this higher number? Because it is on the right of the number line, so it'll be bigger than B, obviously. It'll be higher than B. C is bigger than B. So I have written C before, and the value of C is
It's
X.
1.3.
How much?
1.3.
1.3. That is the right answer. We can check it here also. 1.3, correct. Yes, that is 100% right. So you have done the questions perfectly, but we have left few questions, and the previous questions you can mark the answers, and we have just left one question, that is question number 3 for this. But I need you to do the chapter test of this first chapter, chapter 1, and that's here, page number 13 to 14. That's it. I can shift this chapter test to the right, a little bit right. 1, 2. So we're having this chapter test here. 11 questions in total. Can you try to do them before our session, next session?
I'm sorry, repeat that again.
Is my voice coming in breaking form, or like is there some speaker problem or some and are you able to listen to me clearly every time I say that we need to rectify the
No, it's
problem?
on my side.
Mm-hmm. What really it is, like what trouble is coming?
My headphones.
Oh, your headphones are like not working properly or what?
I can hear you, but sometimes it goes in and out.
Oh, okay. Then you can try for any other headphone, or you can try for the speaker maybe. Okay, so I was telling you about chapter 1 practice test. If you will try to do them, these 11, 12 questions before our next session.
Yes.
Wonderful. So this will be on our link, which I have sent you already, whiteboard link, and you can mark the answers here so that I can check them before our next session. All right.
Okay.
Any questions for today?
No.
All right then. So we'll meet tomorrow at 8 p.m.
Okay, thank you. Have a nice day.
Thank you. You also have a great night. Bye bye.